Hello, this is Patrick at OneCNC West, and what we're going to do in this training video is finish applying toolpath to our part using OneCNC Mill Professional. Now, in previous videos, we completed applying toolpath to the very first side. In this video, we're going to flip the part and apply toolpath to the second side. Now, before we get started, we should talk a little bit about toolpath groups. If we head over here to the NC Manager, you're going to notice we have a toolpath group called Toolpath Group Number 1. Notice that all the machining operations for the first side are located within that toolpath group. For this exercise, I want you to think of a toolpath group as a setup out there on the machine tool. For this part, we mounted the part within a vise and we applied all the toolpath. So why don't we rename our toolpath group to reflect that? I'm going to double click. And within the NC Processing dialog box, I'm going to give the toolpath group a brand new name. In fact, why don't we call this Setup Vise? I think that looks good, so let's click OK. All right, so again, think of a toolpath group as simply a setup out there on the machine tool. Now, when we flip the part over, we're going to need to use a different setup. In fact, we're going to be using soft jaws. Because of that, we're going to need a brand new toolpath group. To make a toolpath group, very simple. Just head over to the NC Manager, right-hand mouse click, and select New Group. While we're at it, why don't we rename this as well? I'm going to double click, and again, within the NC Processing dialog box, we're going to give this a brand new name. Let's call this one Setup Soft Jaws, just like that. Very good. So we'll click OK. Now, there's a couple things we need to do. We're going to need to create a construction plane on this side to help OneCNC understand where we want to machine. We're also going to use the construction plane to help locate the X0, Y0, Z0. In fact, when this part's mounted on the soft jaw, we'll probably indicate off of this upper left-hand hole and create the datum right there, the X0, Y0, Z0. So while we're talking about that, why don't we go over to the Command Manager, select our Point tool, and why don't we create a point at the very center of that hole, just by left-clicking, and when we're done, we can right-hand mouse click. Now, the reason why we're doing that is I'm going to use that point to help us locate our brand new construction plane. Very good. So to create a construction plane, head down to the lower left-hand corner, select your Construction Plane tools, and within the Construction Plane Tools dialog box, you're going to notice all the commands listed up here at the top to create a brand new construction plane. We're going to use this option that allows us to create a construction plane through 3 points. So I'm going to left click to activate. The very first point we select, that's going to be the datum, the X0, Y0, Z0. The second point we click, that's going to designate the X positive direction. And the third point we click, that's going to designate Y positive. I'm just going to left click just like that. Very good. And if you look in the lower left-hand corner, you're going to see that construction plane gnome showing us exactly where the datum is. Now, we don't want it there. We really want to move that datum to that point. We can easily do that by using this command, the very first command called Position Plane. Just simply activate that, take your cursor and left-click that point, and that's it. We've now created a brand new construction plane and it's located exactly where we want. Now, though you don't have to do this, you can save the construction plane if you'd like. You can click Save and then give it a name. I might simply call this Side 2. That looks good, so we'll click OK to that. Let's make sure our Side 2 construction plane is selected. And if we'd like, we can close down our construction plane tool. So I'm going to go ahead and click the little X right there. Very good. Let's head back over to the NC Manager. We need to tell OneCNC that we want to start machining on our brand new side. To do that, we're going to come up here to where it says Set Machining Axis. We're going to left click, and within this dialog box, we're going to select 3-axis repositioned. This tells OneCNC to use the current construction plane and the current datum for all of the new machining operations for our brand new toolpath group. Very good. So we have 3-axis reposition selected. We'll click OK, and you'll notice up here the little icon now says 3P for 3-axis repositioned. All right, now it's time to apply our toolpath. Let's head back over to the Command Manager, and from here we're going to select our stock toolpaths. For this machining operation, we're going to be using facing. So I'm going to left click, and as soon as we do that, OneCNC wants us to select the boundary for the facing operation. I'm going to select this rectangle that we had created earlier to define our stock. So I'm simply going to left click, and when I'm done, I can right hand mouse click. Now, just like with all of our previous machining operations, the very first dialog box is where we define a tool. Again, you can define a tool manually, or you can select a tool from the tool library. In this example, I've selected a tool from the tool library. And just as a refresher, you can access the tool library by left-clicking on the tool graphic or by selecting Tool Changer. In this example, I chose a 2-inch diameter face mill. This is going to be in turret position number 1. I am going to up the RPM up to 1200, and I'm going to up the feed rate to 10 inches a minute. That looks great. For tool type, we're going to be using a face mill. Overall length, that's set at 1 inch, 570 thousandths. That's how far the tool sticks past the holder. And we have a flute length of 460 thousandths and a diameter of 2 inches. I think that looks good. Let's click Next on that. Now for clearances and depths, our rapid Z plane, that's 200 thousandths. Remember, this is your clearance, your Z safety plane, and that's designated by this red grid. It's all dynamic, so if you type in new values, you'll see these grids move accordingly. The plunge clearance, that's where the tool is going to start to feed down. That's designated by these little black angles here. That looks good. Material Z top, that's designated by the gray or the white grid, and same with final Z, which I have set at 0. So material top 0, final Z set to 0. All that looks good. Let's click Next on this. Now for approach distance, we're using the default value of 110% of the tool radius. That simply means that when the tool approaches the boundary, it's going to start 110% of the radius away from the boundary. That way the tool isn't plunging down into the stock. It's going to start outside. A toolpath angle of 0 means that our toolpath is going to be parallel to the x-axis. For tool stepover amount, I'm using an auto stepover of 75% of the tool diameter. If you don't want to use a percentage of the tool diameter, you can uncheck this and you can type in the decimal equivalent. For example, you might say I want the tool to step over 1 inch 250 thousandths. And for this toolpath, I think that value is just fine. For toolpath type, there's 3 different styles. There's spiral, zigzag, and one direction. One direction is going to give me a little better finish, so I'm going to use one direction and we're going to climb cut. Let's click Finish on that and let OneCNC generate the toolpath. Very good. Now if we look over within the NC Manager, you'll notice that within our brand new toolpath group called Soft Jaws, we have our very first machining operation called facing. Notice also that there's a little tiny arrow to the left of the facing machining operation. That little arrow designates that the part has been moved to a new location. In our example, the part's actually been flipped and placed inside of Soft Jaws. Now let's take a look at simulating the toolpath. We can take our cursor and we can right-hand click on any one of our toolpath groups. I'm going to right-click, and instead of selecting Simulate Rest, we're going to select Simulate All. Simulate All means that OneCNC is going to simulate all of the toolpath groups, and that's exactly what we want. So I'm going to select Simulate All, and from our NC Solid Verification dialog box, let's designate how we want the stock defined. For this example, I'm going to be using a solid model I created earlier that's placed on this layer called Stock to represent the stock. So we're going to use Stock Model. We'll click OK and let OneCNC simulate the toolpath. So what we're looking at here is all of the machining operations for side 1. This is when the part's being mounted by a vise. I'm going to slow the simulation down for just a second because I want to show you what OneCNC does to represent the part being flipped or repositioned. You're going to see that in just a second after we drill and countersink all 4 holes. All right, so here's our drilling. Here's our countersink, and that's the representation of the part being flipped. And then there is our facing operation. Very good. Now let's exit out of the toolpath simulator by coming up to the upper right-hand corner and selecting the little X. Let's talk a little bit now about modifying toolpath. I'm going to start by demonstrating how you can repick geometry. For this, let's head back over to the NC Manager and let's take a look at our profile basic machining operation. This operation actually profiled all the way around, and the tool did not cut inside the cutout here. So to repick the geometry, all I need to do is take our cursor, right-hand mouse click on the machining operation, and select this option called Repick Path. That's going to allow us to reselect the geometry. Once I select Repick Path, I can take my cursor, designate where I want the profile operation to start. Remember, the arrows designate the side and direction. I want to be on the outside and climb cut, so I'm going to left click, and then now OneCNC wants me to select the very end of the profile. As a shortcut, I can hit the F3 key on the keyboard, and that will select the rest of the geometry. Once we've done that, I can right-hand mouse click, and now you can see the toolpath has been regenerated, and now the profile operation recognizes the new geometry and is now profiled inside of the cutout. Now, you also have the ability to rearrange the order of machining operations. This is very simple to do. Let me demonstrate. Let's head back over to the NC Manager, and let's say that I'd like to take the profile operation and move it after the Cut Chain 3D command. All I have to do is press down on the left mouse button, and then I can drag the machining operation exactly where I want it and then let go of the left-hand mouse button. It's as easy as that. Now, don't be too concerned about the numbers to the left of each machining operation. Those simply designate the order in which they were originally created. If you'd like, you can renumber these, but again, it's not something that you have to do. If you'd like to renumber, all you have to do is double-click on the toolpath group, and within the NC Processing dialog box, select this option called Renumber Operations. Click OK to that. OK one more time. You'll see now that the machining operations have been renumbered. Now let's take a look at editing machining operations. There's actually 3 ways to do this. The first technique is to take your cursor and just simply double-click on the machining operation. Once you do that, within the NC Processing dialog box, you can select the option called Edit Operation. From there, you can make as many changes as you'd like. For example, why don't we change the RPM to 4300? That looks good, so we can click Next. We'll keep clicking Next all the way through, and then when we're finished, we can click on the Finish button. It's asking, do we want to repick the machining boundary? I'm going to say no to that. Now, another technique to edit a machining operation is, instead of double-clicking, you can right-hand mouse click and then select Edit Operation. This works exactly the same way as if we were double-clicking on the machining operation. It's identical. You make whatever changes you want. For example, we'll change the RPM. Let's also change the feed rate. We'll click Next on that. Next, 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 and Finish. And again, it's asking us, do we want to repick the boundary? I'm going to say no to that. All right, now the third and final way you can make edits to machining operation works just like this. Let's go back to the NC Manager. I'm going to drag this little boundary up just a little bit. And what you can do is this. If you take your cursor and left click on any machining operation, you have access to some of the more pertinent or relevant options within that command. For example, we could change the turret position from 4. We might want to change that to something like 9, and then click the little check button there. You can also change the RPM. Why don't we reduce this to 5,500? Click check on that. And feed rate, why don't we up that to 10 inches a minute, and then click the check button. The advantage to this is that you don't have to right click or double click on a machining operation and go through all of the dialog boxes. You can make your changes here and quickly make whatever edits that you'd like. It's very powerful. If you want to delete a machining operation, just a right-hand mouse click and then select Delete Operation. You also have the ability to duplicate an operation as well. Let's take a look at creating a setup sheet. To do this, take your cursor and double-click on any one of your toolpath groups. I'm going to double-click, Once we do that, within the NC Processing dialog box, select Job Sheet. From there, OneCNC will create a PDF file, which is your setup sheet. If we take a look, you can see that the toolpath group name is provided, the name of the post processor, the date, the cycle time. If we keep scrolling down, you can see a list of all the tools that were used. And if we keep pushing down through the job sheet, you can see there's a nice graphic that displays the toolpath as well as the X0, Y0, Z0 location, the datum location. And if we keep scrolling down, you'll notice that each machining operation is defined separately with all of the relevant information, such as cycle time, final Z depth, material top, work offset, coolant, tool station, and much, much more. The OneCNC job sheet is a very powerful document and a great supplement to any CNC program. All right, let's take a look now at creating a CNC program. To do this, the process is very similar. You want to take your cursor and double-click on any toolpath group. Once we double-click, we want to select the post processor that we'd like to use to generate the CNC code. Remember, the post processor is what converts all of your machining operations into CNC code. To select a post processor, click the little down arrow and then simply select whichever post processor you'd like to use. For this first example, why don't we use a Haas? That looks good, so I'll click Post on that. Here's where we can designate a name and location of our CNC program. I'm just going to call this Setup 1. That's going to be the name of the CNC program. We'll click Save, and then OneCNC is going to generate the CNC program and take it inside of the text editor. I'm going to close the text editor down, and why don't we create a CNC program for our SoftJaws toolpath group. Same thing applies, just double-click on the machining operation. Within the NC Processing dialog box, select the post processor. Now, you don't have to select the same post processor. Let's say, for example, the Haas machine tool is busy and you're going to need to use a different CNC machine. Well, for this, we could choose a different one. Why don't we use a Fidel post processor? Now we'll click Post. Again, this is the opportunity where we can give our CNC program a new name. I'm going to call this Setup 2. We'll click Save on that and let OneCNC generate the CNC code. The OneCNC text editor is very robust in that it provides tools to do things like perform a search, copy, replace. You can even change the format and font of the text as well as renumber the machining operations if you'd like. There's also calculators provided, and if you'd like, you can also upload and download your CNC programs to and from the CNC machines using the included OneCNC RS-232 software. All right, that's it for this video. Thank you so much for watching, and I look forward to seeing you in the next video.